Hi, what I want to do is in the previous video, I did a beam design, and in this one, I just want to show you the Radial Beam Designer program. What's critical about understanding this is the fact that the Radial Beam Designer is primarily a designer. Most programs are analysis, so you guess at what it is and you see whether it works. Guess at what it is and see whether it works. But Radial Beam Designer actually designs it. So on the fly, it will design the beam for you. It doesn't exist very much, strangely, in our world. Everything's generally a design program rather than um, an analysis program rather than design. So guessing the answer beforehand doesn't make a lot of sense to me. If I go into Radial Beam Designer, which comes from it's a module, so you've got to set it up. And what I'm going to do is actually show you what the, how this Radial Beam Designer works. And in the previous example, we had a beam that was 5.5 meters wide. And I would normally, for a beam carrying load, I would normally put it as storage and get the short-term deflection equal to 1 and the long-term deflection equal to 0.6. It's almost certainly going to be governed by short-term, and I just want it to be equal to 1. Radial Beam Designer requires it to be fully lateral restrained. If it isn't fully lateral restrained, it doesn't do it. Check vibration. For this beam, I'm not going to check the vibration. Even though it's a floor beam, I'm not going to check the vibration because it's not an issue because it has so much dead load on it. And this is the deflection criteria. And as I said in the previous one, for walls carrying masonry, right, which is a brittle finish, we generally say that we're using something for the dead load between 400 and 750, between 500 and 750. That's what we set this to. And actually, you can do the staged uh, masonry beam, and it'll give you that 500. A prop masonry beam will give you 750. So these are the difference between these two internal settings is the initial dead load deflection. So that's the dead load that will happen as soon as you release the props. And that's what you want to try to control. Stage stage kind of says that we're using the wedges to pre-deflect the beam. That's what we mean by stage. And prop means that we're only going to do a pseudo. We always recommend that you do some sort of pre-deflection of the beam. In other words, transfer the load to the beam before you release the props. So it's just a matter of how you do it or how much risk you put on the actual construction process. So 750 will give you a different answer to 500, of course, a bigger beam effectively. In this case, I don't want to add a pre-camber, but you can add a pre-camber if you want. But because we're doing pre-deflections, then there's no reason to do a pre-camber. And then you want to add the loads. So we have, I'm just going to start by adding the self weight. And I'm going to add the 3 UDLs that we had. So remember we had UDL1, UDL2, UDL3. And I'm going to add those as partial UDLs. So you just press add, and I even have the opportunity to put names. So start, and it defaults to the full beam. So that's great. It's 0.5 and 1.5. I'm going to add, and the next one was the roof, and that was 0.4 and 0.25. And I'm going to add the brick wall, and that was 13.2 dead load and 0 live load. And then I'm going to add a point load, and this was from the brick wall as well. And that location was 1.7. For those of you who are clever enough, you would have known that I calculated the point load incorrectly. So it's actually 30. Here's where you choose the material. So I'm going to use a UB, and it will automatically choose the beam for you. So that's a 460 UB 67.1. And let's say we got clever and wanted to, and it's to 360 UB 44.7. If you want to force an automation, press A. Get out of a cell and press A, and that automatically selects what you want. But again, I'm going to go back to 1. It's telling me I'm failing, so I'll press A again. 14 UB 53.7, and it's at 94%. So that's the beam. You could actually make a custom beam if you want to trim the flanges off or make a section, different type of section. You can actually add a custom beam. And then this gives you the analysis of the results. So span on 750 is 7.3. And here's the design results as well. And it actually gives you a number of different ones. So for example, if you use 2 members, so this is if you use a single member, but if you use 2, 3, and then, of course, it'll give you the bending moment diagrams. So, of course, as any good engineer would, just do a quick check of this and see whether these results are good for you. So that's how we use Radial Beam Designer. And if I close that and come back to the main app, you will see that it will automatically update that information. And you can actually edit the beam. I didn't give it a beam name in the other one, but we would normally call it 1B1. And when you open it up, that's where this will live. And actually, if you change it here, if you change it to 1B10, just be patient, it'll update. So that's how you use Radial Beam Designer.